This sum, you can read the question for yourself. There is a mass C and there is a mass B. The bigger mass C and there's a pulley which connects it like this. There's a force here. Okay, and so because of this applied force here, there can be a pseudo force MA. Okay, look at this. This can come backward and it has to remain stationary. The whole thing should be at rest. There is a coefficient of friction here and here, but not between C and the floor. There's no coefficient of friction. So there'll be a tension T and a tension T. And this should not happen. It should not come back, which means the T on the right should be countered by a frictional force on the left, so that the T minus F should be equal to MA, so that the pseudo force does not happen on the block and the block remains stationary. Therefore, you understand how I'm marking the frictional force to the left. So you know that there is an mg which is acting downward, and there's a normal reaction, and this frictional force is equal to mu into normal reaction, which is mu into mg. And since there is you have to have a force ma in this direction to counter the left ma, it's T minus frictional force is equal to ma, T minus mu into mg is equal to ma, T is equal to ma plus mu mg, and you get a first equation. Let's go to second block. There is an mg which is acting downward, and there is a normal reaction n dash here, and you know n dash is equal to ma in this case, and there is a frictional force, and the frictional force here will also act in the same direction as this. So frictional force is equal to mu into n dash, which is mu into ma, and resolving the vector, you know T plus F is equal to mg for it to be remaining stationary, and therefore T plus mu into ma is equal to mg. T is equal to mg minus mu ma. So then you can equate both the tensions. So thus you get an ma plus mu mg is equal to mg minus mu ma. So then consolidating ma and ma, you get ma into 1 plus mu is equal to mg into 1 minus mu. So you get an m and m getting cancelled. A is equal to g into 1 minus mu by 1 plus mu. So this will be the acceleration. And they are asking for force. You know the net for mass is capital M plus 2m. So A into capital M plus 2m into g into 1 minus mu by 1 plus mu would be the force, which is the minimum force. This is the force minimum, or this is the acceleration minimum. Okay, when would what about maximum acceleration? The maximum acceleration is when it begins to move. The force is so much maximum that the blocks begins to move. So in that case, the entire friction's direction would change. The friction that are marked here in the green, which is on the left, will become to the right, and the friction here that are marked upward will become downward. So these equations which are marked with the friction is going to just change. That's all. So when it just changes, you know, in this case, it's going to be T plus F is equal to ma, and this is going to become T minus F. Okay, in other words, T minus F is equal to mg. So accordingly, you're going to change this equation. T plus F is equal to ma, and T minus F is equal to mg. And what is the F in the first equation? T minus mu into mg is equal to ma. The second equation, F is mu into ma is equal to mg. What is T therefore from the first equation? Ma plus mu mg. And T from the second equation is mg plus mu mg. So there's a plus here, and this so when it goes, that's it will be minus, and mg plus mu ma. Equating both, ma minus mu mg is equal to mg plus mu ma. So ma can be consolidated. So mu in ma into mu plus mu minus 1, ma into mu minus 1 is equal to mg into okay, I'm going to take this to left side. So I'll get ma into 1 minus mu is equal to mg into 1 plus mu. So m and m this get cancelled. A is equal to g into 1 plus mu by 1 minus mu is for maximum acceleration, and therefore the force maximum also will be 2 m plus capital M into 1 plus mu by 1 minus mu will be force minimum. So then therefore the force lies between maximum and minimum value. The force have to lie between these two values, so that here it's just beginning to slide, and there it's, so that will be the force, so that it will keep the small block at rest with respect to the bigger block. The maximum and the minimum force, whenever they ask you maximum minimum force, you have to assume that it is not moving, then it is moving, and define the lower and the when it is not moving, the friction's direction is in one direction. It starts moving, it's in another direction. So that's something you need to note down. So let's go to next question. Is the fourth question. The block of mass 1 kg, okay, supposing there's a wall here and a block of mass 1 kg is being pressed on it, and this is the normal reaction. We are pressing on the wall with a 20 newtons force, and therefore the normal reaction is 20 newton. That's all it gives you. That there's a 10 newton acting downward. They have also given another horizontal force. Horizontal force parallel to the wall, it will be like this. You're pushing it like that, 10 newton. So that 10 newton acting downward, and this 10 newton will have a resultant which will be 100 plus 100, which is 2 root 10, and newton will be the force that is acting on it. Now they have given the coefficient of friction that exists between the wall and the block, which is 1 by 4, and the frictional force, if you're going to push it like that, will exist. The frictional force will be in the opposite direction. The frictional force is equal to mu into normal reaction, which is mu is 1 by 4 into normal reaction is 20 newton, so then therefore 5 newton. Can you see 20 root 10 is greater than 5, so definitely the block will move. The question is, will the block move? Yes, the block will move. Okay, so what will be the acceleration of the block? You know, acceleration is F net by M. Net acceleration, which is net force, is 2 root 10 minus the frictional force by the mass, which is 1 kg. So then this is 14, what is 10 root, see 10 root 2. What am I writing? It's 10 root 2 newton. So it's 10 root 2 minus 5 by 1. So then it's a 10 into 1.414 will be 14.1 minus 5. So 14.1 minus 5.0 is 1, and this is 9. So 9.1 meter per second square will be the acceleration. 1/4. Yeah, so that's about it. That's the sum. It's a beautiful sum, because if you don't know that the wall is going to be like this and the force that is parallel to the wall will be in this direction, you can never be able to do the sum. So make sure you understand the question. So next thing is, you have an incline of 45 degree and a 45 degree, where there's a mass m and there is a mass of 2 kg, and running over a pulley is here, and therefore this is tension, this is tension. Then they are saying that the coefficient of static friction is 0.28, the coefficient of kinetic friction is 0.25, which exists between the block and the surface. Find the minimum and the maximum value of m, so that the system will be at rest. Okay, so let's consider that m is lesser than 2. The m is lesser than 2, and let's do the sum. M is less than 2. So when m is less than 2, you know the acceleration will be like this, and it's going to go up, and therefore the frictional force direction will be in this direction, and therefore here the frictional force will be in this direction. And let's draw the free body. This is mg, and this is a normal reaction, and there's an mg down, and there's a normal reaction, and this is theta, which is 45 degree, and so this is mg cos 45, and there will be additionally an mg sin 45 here, and here with regard to this there is an mg here, which makes an angle theta here, so this will be mg cos 45, and there will be an mg sin 45 here, mg sin 45 this side. So then now we can resolve the vectors. Considering that this is going to be accelerating down, you know that what about the friction? Yes, the friction is here, and so we're going to resolve this right side. You have, it's going to accelerate down, so mg sin 45 is equal to t plus f, and mg sin 45 is equal to t plus mu into normal reaction. The normal reaction in this case is mg cos 45. So you know sin for mg by root 2 is equal to t plus mu into mg by root 2. So t therefore is mg mu an mg by root 2 is common. Mg by root 2 is common, you get 1 minus mu. Taking this to that side, 1 minus mu. So that will be the t according to right side. Let's do the left one. What is it? It's going to accelerate up. So then therefore it's t is equal to f plus mg. Okay, t is equal to f plus mg sine 45. T is equal to f plus mg sine 45. T is equal to f itself is mu into that normal reaction, which is again mg cos 45. But here you know m is 2, so you can just replace wherever m is as 2. Okay, whereas here it's 2g by root 2, and here it is m is m only. So mu m, what did I say? Mu into normal reaction, which is mu into mg plus mg by root 2. Okay, so mg by root 2. Mu into normal reaction, but normal reaction here for the left side is mu into again mg cos 45. So mg by root 2 plus mg by root 2 is equal to t. So then therefore t is equal to mu by mg is common, by root 2 is also common, 1 plus mu. So that is the tension for the left side, and you get the tension for the right side. And you don't know what is m, so you can both equate both the sense. And mg by root 2 into 1 plus mu is equal to 2g by root 2 into 1 minus mu, where g and g get cancelled. Therefore root 2 also get cancelled. So m is 2 into 1 minus mu by 1 plus mu will be this unknown mass m. This could be the value of m. Let's see. But they have given, this is all mu static. We have assumed everything to be a static friction in the first case, mu is maximum, limiting friction. So which is 0. What have they given? 0.28. So you can fill in 2 into 1 minus 0.28 by 1 plus 0.28, which will be 2 into 1.00, 0.28 will be a 10.297. So this will be 0.72 by 1.28. So therefore 2 2s are 4, some 2s are 14, 1.28, and they're saying it's 9 by 8, is it? 9 by 8 kg. So I'm getting a 144 by 128. Let me cancel this. This is 72 and this is 64, and so 9 8s are 72. 8 9 by 8. Yeah, I'm getting the answer. 9 by 8 kg is the unknown mass, and that could be the considering it has got lower value. Now we can consider the whole setup to be having m is greater than 2, so that it's going to slide on the other side. The directions of the frictional force is now going to reverse, that's all you know. So then so should I do it like this, or should I do the diagram itself? Okay, so there is the mass m and there's 2 kg here, and okay, if this is greater, this is going to have an acceleration like this, going to have an acceleration like this. So the frictional force will be here, and the frictional force in this case will be here. So basically everything remains the same, just the direction of the frictional force only has changed. So when you write this equation, you should write T is equal to minus F plus mg sine 45. Instead of doing all this, you can directly take the same equation. That's very easy. So instead of that's a time saving method. So you just have to see that the friction direction is going to change. So that's T is equal to minus F plus mg sine 45. T is equal to minus F, or T plus F is equal to mg sine 45. T is equal to minus F plus mg sine 45, and here 2g sine 45, 2g sine 45 is T minus is equal to T minus F, is equal to T minus F. So what is T from here? mg by root 2 minus frictional force, which is mu into a normal reaction, where there will be always mg cos 45, mg cos 45, which is mg by root 2. And here what will be T is 2g sine 45, which is root 2, plus F is equal to T, where F itself is mu into normal reaction, which is mu into mg by root 2 is equal to T. So then if I take this T is equal to mg by root 2 into 1 minus mu in the first case, and t will be equal to m is 2 in the so it's 2g by root 2, 2g by root 2 into 1 plus mu in the second case. So equating both this, mg by root 2 into 1 minus mu is equal to 2g by root 2 into 1 plus mu. G and g get cancelled, and root 2 and root 2 get cancelled. M therefore is 1 plus mu by 1 minus mu, and in that case if you're going to put 1 plus 0.28 by 1 minus 0.28, 1 minus 1 plus 0.28 by 1 minus 0.28 is 1.28 by 1.28 by 1.44. 1.28 by 0.28, it will be 2, and that will be 0.72. So 128 by 72. 128 by 72 will be like when I cancel it with 4 tables, 4 3s are 12, 4 2s are 8, 4 1s are 4, 8 4s are 32. So 32 by 8, but it's 32 by 9. What is the mistake again? It's 2 into, oh, did I forget the 2? That's 2 into, okay, and I forgot the 2. Okay, so it's when it's 2 into, it will be 32 by 9, 32 by 9 kg, and that will be the maximum and minimum value of m, the minimum maximum value of m for which the system remains at rest. Okay, the system remains at rest. So next is B. Find the acceleration of either block if m is given minimum value. Calculate the first part and is generally pushed up in inclined plane in a short while. I don't understand this question. Find the acceleration of either block of m, either block. If m is given the minimum value, okay, calculate the acceleration of either block if m is given minimum value, calculated in the first part, yes, and is gently pushed up for a short while.